In this tutorial we will talk about adding joints between rigid objects in Robotstudio. There are 4 types of joints available: lock joint, rotational joint, prismatic joint, ball joint. The physics simulation in Robotstudio can be augmented by joints. A joint is a constraint that controls how 2 rigid objects can move in relation to each other. A rotational joint allows rotation around an axis. A prismatic joint allows translation along an axis. A ball joint allows rotation in any direction around a point. A lock joint allows no movement, locking the 2 objects together. In the first example we will create a hinge using a rotational joint. The parts connected by the joints must have physics behavior enabled, so we set them as dynamic. Collisions between the 2 objects connected by a joint are ignored by the rigid body simulation. Therefore it can be useful to create intermediate parts connected by lock joints. We create lock joints to connect the knuckles to the hinge plates. The position of the lock joint does not matter in this case. The joints can be viewed in the Physics browser in the Modeling tab. For the rotational joint, we must specify the connected parts and the rotation axis. Snap Mode Center is used to select the center of the knuckle. A preview of the rotation axis is displayed in the graphics. Click Create to create the joint. We can test the joint by dragging the connected parts. Next, we will create a prismatic joint. We set the base of the device as fixed. The moving part is set as dynamic. We must specify the 2 connected parts and the axis of translation. A preview of the translation axis is displayed in the graphics. When we have created the joint, we can test it by dragging the dynamic part. Lastly, we will create a ball joint. We set all parts of the device as dynamic. The ball is connected to the base of the device by a lock joint. For the ball joint, we must specify the connected parts and the center of rotation. We use Snap Mode Gravity to select the center of the ball. Click Create to create the joint. As before, we use drag to test the joint behavior.